Hi everybody, this is Konstantin Abramov, and today's tutorial is about computational fluid dynamics (CFD), which we research in uh, SolidWorks add-ins, which calls flow simulation. This simulation was made for centrifugal pump and suction single stage centrifugal pump. We research different version of centrifugal pump for different impellers, blade curvature, for forward curvature and outward curvature blades, and for different rotation direction, clockwise and counterclockwise, and watch what happen in inside the pump when we have different factors of analysis. I have a chart for report. First analysis would be for forward curvature blades and clockwise direction rotation. Second analysis would be about forward curvature blades and counterclockwise rotation. Third would be for backward curvature blades and clockwise direction of rotation. And last, fourth, would be for backward and counterclockwise. For better understandings what I mean about forward curvature blades, about direction, counterclockwise, clockwise, I show you schematic pictures. This forward curvature and clockwise direction, forward and counterclockwise. This backward, clockwise, and backward with counterclockwise. This picture I'm adding in this chart. Need to make some smaller. Yes, ready. I have some problems with English, but words which I don't know, I will translate with Google Translator. If it would be need. I have a model which was be modeled in SolidWorks for volute casing, and for impeller. There is a single close impeller for centrifugal pump. Let's start with first analysis for curvature weights and clockwise rotation. You need to open or add in full simulation in SolidWorks. Go to Tools, Add-ins, and mark SolidWorks Flow Simulation 2050 in Add-ins. And when you go to Tools, you find Flow Simulation in your text. What you need to know about model preparing to flow simulation. All holes, all fluid spaces should be closed. For example, I close these holes by pipes, inlet and outlet pipes. Let's build these pipes. I create a new part, open this part, save as this part, and I call on this part, for example, inlet. Next, I need outlet. Create new part, open, save as, and call it outlet. Yes, ready. Let's build. Open inlet in edit part, and we can build pipe for this flange. Convert entries. First need to create sketch on this plane and convert entry. This edge. Yes, ready. Also, let's create wall thickness. I think maybe 5 millimeters, 6. Let's do it 6 millimeters. Have some problem breaking. 6. Ready. And extrude this pipe. For example, 250 millimeters. I can open. Also, this hole should be closed, but you can close in model, directly in model, this hole, but in flow simulation you have a function for close this hole. I show you second version with using flow simulation. And now let's build outlet pipe. Edit part, create sketch on plane, convert entries. Next, make offset entry 6 and extrude this pipe in y-axis direction. For example, it would be 2 meters. Yeah, good. Oh, big, very big. 1 meter. half meter. Yeah, half meter will be good. Ready. Uh, Also, we have a open space in the back of Empower. You see clearance there. Actually, in a real pump, it closed by casing plate. But we close it directly in wallet casing. Open this wallet casing, and previous I close this hole by extrude boss. Ready. This this hole is closed, and I have full close fluid space for fluid running and Empower rotating. Also, about Empower rotating, if you want to edit rotation zones, you must build this zone on Empower. For example, I show you. Let's hide some components, casing, and adding new part. Call this part like rotating wing, and edit, create on all edges of Empower. I'll show you how you can do it. I need to find correct feature in my Empower. Yes, this sketch I will use for entries. Choice plane in rotation when, and build sketch there. Yes. This rotation when will be looks like an Empower but without blades. It's like a zone of rotation. I think you understand me. Yes, ready? This is a space of rotation for Empower. You can choose rotation per minute, radian per second for rotation zone. You can choose direction of rotation, clockwise, counterclockwise, but this all function you will watch in analysis. Alright, now I have pipes, Empower, casing, all rotation zone, all my holes closed, and let's start to analyze it. Go in Tools, Flow Simulation, Project. I create new project, new, call it forward, only call it like 01 first, and automatically create a new project. But also you need create a wizard for this project. For example, sorry, I make a mistake. Need to create from beginning, project, and you must create project with wizard. Yeah, co project like 01. Next, choice units. You can use CI units. You can use American units. You can use custom units. You can use all your preferably units. I'm use for this project CI system units. Next, we research and internal. We need research internal surface of this pump. Choice internal. Exclude cavities without for condition. Rotation. Yes, we need local region. Surrounding global rotation. Choice. We can use different types. Gravity, for example, time dependent, radiation, heat conduction in solids. Also set their direction of flow, which direction flow start to go. X. This direction is x-axis. Next, what we analyze? We analyze water. This pump, actually, this pump, I think for acid. Is phosphoric or nitric acid pump, but actually let's research in this tutorial water. Choice water. Choice flow types, laminar only, turbulent. We need that's better to watch on laminar and turbulent flow type. Next, sorry, I don't choice water. Edit. Yes, ready. Laminar turbulent cavitation. We can find cavitation zones. Next, roughness, wall condition. For example, if I use casting roughness would be 25 micrometers or 50 micrometers for casting casing. But let's edit there 25 micrometers. Next. Initial condition. Initial condition. We have pressure, atmospheric, and temperature. Temperature. We have 20 Celsius. It's 293 by Kelvin. But I don't research this function. I think I can do it in soon future. Let's leave it. Next, we need set a mesh for calculation for the results. Let's choice five quality grade. It's quality grade for meshing. Let's choose 5. Finish. Now we have project number 1. What we need to do there? I think need to close. Need to close this holes. Yeah, need to close this holes in pipes. Sorry. this. Ready. Make it transparent. Next wall. Pipe there. Make it transparent. Also make transparent rotation zone. Rebuild. The geometry of model or project setting have been changed. Do you want to reset the computational domain? Yes. Yes. Yeah. And if you see now, we have a parallelepiped. This parallelepiped only for flow zone. Now all our zone is closed by cap, plug, and this parallelepiped cannot be built before because I have opened pipes. Now we have an parallelepiped for calculation. This zone will be only for calculation of like we chose internal cavity. Let's prepare a model for calculation. We use in first analysis we use forward curvature blades and clockwise rotation. Let's choose and edit this region. Insert rotation, choice rotating line. We see rotation in counterclockwise direction. But what we do, we set minus, for example, 3000 RPM. RPM. And if I fix this and open next time, we see conversion in radian per second. I think everything fine. We can use radian per second, maybe 2000 RPM. Did you see this value is changed? System automatically convert units. Let's use 3000 rotation per minute. Yes, ready? We set rotation zone. Next, we must insert boundary condition. For example, it would be an environment pressure. And this unit choice phase for this boundary condition. I think to choose and cap plugs of pipes, outlet and inlet pipes, but we can click on this face inside the pipe. I show you how you can do it. Click right button on mouse and choose select other. Select other, you watch different faces which switch by orange color. We need this face. Choice, yeah, ready, and see this face in the boundary condition. You can set environment pressure. Use environment pressure is atmospheric. Alright. Next, boundary condition for outlet. Edit, insert, choose environment pressure, select other, chooses phase inside the pipe. Okay, ready. Which next? You can insert global. You can choice or insert goals which you wanna research. For example, you can research pressure, static, total, dynamic temperature, different density, mass, velocity, um, in velocity in different summary velocity in different direction, time, viscosity, different parameters. Also, you can choose an average, minimum, average, maximum value of these parameters. Let's choose average. For example, pressure, static, total, dynamic. Also, we can use temperature, velocity, for example. Force. Let's use force on wall of casing, shear stress, turbulent energy. Different. I think it's enough for now for this tutorial. Alright, ready? Next, results. What? Cannot find results because we not solve this model. What we need to do? We need to solving this model. This model is ready for calculation, and I can press run. There you can create a new calculation. You can choose number of cores. I have 4 cores on my computer, and press run. Now solving was started. My computer show now it calculate, and in some time it show how much time it need for calculation. I think I must stop video recording because I use all my cores and continue this recording after solving of first model. Now my computer is calculate time for this solving, and estimate time is 18 minutes for solving of this model. Insert goals, insert preview, yeah, really. I can watch and preview of solving. Let's do it. Yeah, did you see? It's pressure calculation. We can use we can watch interactivity of calculation. If anything goes bad, you can stop your calculation. continue it after solving and show you result analysis. Okay, let's back again. Solver is finished. Uh, it's some overtime for this calculation. My computer finished it by 10 minutes. Close this solver. Back again. Rotation region. Ready. And let's watch what these add-ins for SolidWorks give us. We can watch mesh. 3D view. For example, like this. But this result is not interesting for us. It's only calculation region. We can watch cut plots. We can insert this cut plot. We can move cut plot in all direction of our calculation zone. We can change plane of projection for cut plot. Example, right plane. You can move plane cut plot there. Let's watch what will be gone in impower surfaces during the rotation. Let's choose displaying of results by like contours, isolines, vectors, streamlines. We need result. Also, we need to choose result which we wanna watch. Example, pressure, number of levels. We can increase this level to 20 and okay. We have cutted plot. Let's hide some components there. And we can watch what happened when our impower rotate in clockwise direction. Did you see this zone? It's like a swirl, whirlpools, yeah, whirlpools or swirl. There, we can also choose edit this definition, and we can watch not pressure, we can watch temperature. I'll delete this and create new right plane. Yeah. We can change values for temperature, for example, like this. we can, I think we can animate. Yeah, we can animate this cut plot. It's like a go forward and back. Stop animation. Oh, it's we don't need. It's capture of result. We don't need capture. Delete this cut plot, and also surface. You can insert surface plots. Let's try surface plot. I need to choose surface. For example, it would be a wet surface inside the casing of pump. Choice result velocity. Change this definition. No change. I don't know how to use this surface plot because it's my first analyze. Let's watch trajectories of flow. Yes, we need to change choosing. Need to choose any. Sorry. Need to choose any face sketch. I think I can choose. Cap inside surface of cap inlet pipe. Yeah, this number of points of result trajectories. Choose there, for example, its appearance for showing, like we wanna watch in pipes, in wires with arrows, bands, spheres, arrows. Let's choose lines with arrows, and which parameter we wanna research. Velocity, for example, and check OK. Press OK. Yeah, and we watch flowing of our resultation fluid calculation. Change this definition. Example 50, maybe 60, 70. 70 is very big. 65. Yeah, we have 65. 60, maybe 60 maximum. It's maximum velocity. We have 3D trajectories of our velocity fluidization. Can we also we can play and make this. Did you see? Fluid running. It's not correct. We chose incorrect direction. Direction of rotation for impeller, and in next analysis we use correct direction of rotation and weight curvature, and you watch a better result in next analysis. Alright, let's keep this result, save, stop animation, height 0, show all our parts in this analysis, save, and copy these files in new folder. Create new folder, second analysis, and insert there. Rename files. Open with button in SolidWorks. Choice pump simulation second, and change references on model. As we see, this assembly use volute casing with number 1. We need to change it on number 2. Yes, ready? Impeller with number 1, and we need to use impeller number 2. Okay, ready? And press open. As the geometry of model has been changed, you want reset. Alright, let's reset. I think, yeah, maybe like that. Use a region. Oh, sorry, I'm sorry. Very sorry. Have one opened space. I need to close. Yeah, ready? Let's close it. Yeah, everything right. Let's change I try to change clone the weight, clone, maybe clone, yes, no, sorry. I think this result must be change in directory, in folder. Yeah, it's in folder directory. I'm only change name for this analysis. Also, what I need to change is rotation, direction of rotation with plus volume. Yes, ready? Did you see? It's rotate counterclockwise, like in our picture schematic. I say that I use forward curvature blades, but for this direction of rotation, this blade is backward. This rotation, direction of rotation, and if you see, we use backward curvature blades. Alright. We need resolve. We need run this project. Don't take previous result. New calculation. Use all cores of my computer and run. Solver is opened. And I need to wait when this calculation is finished. Calculation is started. Now is 5 minutes of calculation during time, and need approximately on finishing 8 minutes. I want to show you how you can watch results interactivity. Choose this insert preview. Next, you choose plane where you wanna watch and cut plot. Auto mode of showing. Let's watch in contours on front plane. Result parameter which you wanna watch. For example, let's watch velocity there. Resolution, attributes, image, options, region, and press OK. Yeah, and you can watch what's going on in cut plot of front plane in iteration number 164 now. Minimal velocity is 0 and maximal velocity now is 54.79 meters per second. Also, you can make this cut plot on right plane, for example, and watch what's happened there. Also, we can change parameter. Example, let's choose also right plane and change parameter for temperature fluid. No, temperature is not interesting. Pressure, maybe pressure. Turbulent viscosity. Or pressure. Let's watch pressure. I must stop my capturing software because it takes many resources from my processor, and I need all resources for fast solving of this model analyze. Alright, solver is finished. Closing this solver, and we have second results for counterclockwise for correct counterclockwise direction of imper rotation. And let's watch cut plot example. Insert cut plot on right plane, choose velocity and insert it. Hide some elements. Now I can find the lines, vectors. I can find swirls there. We don't watch swirls of fluid. All fluid going correctly in direction. I like this result, but we have analyzed different results, and I must make this analysis for show what happened in that case. Let's watch cut plot of pressure. Change it on density. We can also use 3D profile. But I don't know how how it's working now. Let's watch trajectories. Yes, we have lines with arrows, alright. Let's change density of arrows on 60. Make it better, or 80. Yeah, better. And let's animate this. If you watch the velocity in outlet pipe approximately average from 20 to 30 meters per second. Also I can find swirl or whirlpools there. Hydro heatings, I think, is on my language water hammer maybe. Yeah, water hammers. I don't watch there, I don't see water hammers. I think that's fine result. And we can begin or continue with third analysis. Let's keep it. Save this result. Go in our folder. Copy. Paste. Change name. Some problem there. Delete. No, it's not more. I think some problems. Need to open again. Change names. Yeah. And open third project. Change references on wallet casing with number 3 and on Empower with number 3. Okay, open. Change name of project on 3, third. Now I need to change model. I need to change model of Empower. If you watch, I will use backward blades. Hide. Open Empower. I think I can make it faster. Yes, I have one blade of Empower. I try to think how I can do that there. Maybe like this. Mirror pattern. Make a mirror pattern on right plane and copy all these blades. Now these blades are crossing together. I need to remove excess bodies, excess blades, this, and this blade. Yeah. Now if you watch, direction for Empower is of blades is changed, but I need to fix some problems in future tree combined with another solid bodies. I think yes, fillet should be, but I think it's not critical to create fillets or any small elements. You need a calculation. You need watch result, and these elements like fillets and other small elements will be access for calculation. Time of calculation would be more higher, larger. Yeah, ready? I change geometry. Also, I need to change Yeah, I need to change direction, rotating, edit, definition, and with minus. Ready? And start to solve. Run. Flow simulation has detected that model was modified. Do you want to reset mesh settings? Yes. We reset meshing. Uh, Now model is remeshed. When I press run, uh, new geometry is remeshed. Choice not choice take previous. New calculation, run, and wait for solving. Certain analysis was finished. Let's watch results in SolidWorks screen. First, watch cut plot show. Need to remove the power. Velocity choice. Right. Yeah. Also, let's edit the streamlines. Did you see this swirl? Swirl there. Velocity lower than in previous. More high velocity on impeller vanes, but in outlet pipe velocity is approximately lower than 20 lower than 20 meters per second, because it's incorrect rotation. I chose an incorrect rotation. For impeller. Let's watch trajectories. Animate this. Yes, if you see some curls there, swirls, curls, it's not a good result. Let's watch pressure, trajectory, pressures. Higher pressure on inside empower rotation vane. Alright, let's finish it and start with force analysis. Rename, sorry, rename parts, rename assembly, and then open with new references. Ready. Last analysis, need to change rotation in counterclockwise, and we have in this I write backward curvature weight, but we have similar direction of blades and rotating. Let's watch what we have get when calculation is finished. But change rotation in another direction. Yeah, ready? Change name for project and run. 1 minute, sorry. Yeah, ready? Need new calculation choice. Run. And wait. Alright, last analysis was finished. And watch what we get. Let's choose cut plot, show it. Watch velocity, yes. Let's check. Yes, we choose velocity. And hide these elements. Did you see? Very fast velocity on empower vanes on empower vanes. Maybe 65 meters per second, and maybe 20, yeah, maybe 30, 40. (32) in outlet pipe. Let's back again. Let's watch stream wires. Stream wires is chosen. I can see curves, swirls, 0. Let's watch trajectories. Hide this pressure. Let's watch pressure on cut plot. Uh, Pressure with minus uh, minus value. Let's watch speeds. Sorry, velocities. And we can make conclusion. We need rotation of power for this pump should be in counterclockwise direction. This direction counterclockwise, but better result I think it's second. Let's make I need some time to make screenshots and edit this in report there, and then we can analyze which of result is better. And now I have a screenshot for all results of for analysis. All these screenshots in report for velocities and pressures researching. If we watch pictures after this analysis chart, these pictures, first analysis, what we get. we get these curves, cavitation on the cavity of pump. It's not good for pump working. Different pressure and low pressure in outlet pipe. That's not good result. Let's watch velocity for this analysis is lower than, I think maximal velocity is 12 meters per second. Let's watch next analysis. There we get velocity, average velocity 25 meters per second. We have good pressure in the outlet pipe. There is good result, and this original result of original pump using. That's isometric views. Next, third result, we also have curves, cavitation, there. Velocity not lower than, not higher than 12 meters per second. And last result, where we have a low minus direction pressure. Let's force analysis. I think better is best result is second. It should be correct. Other also can be correct results, but we choose second. Thank you for watching. Subscribe my channel. Goodbye.